Hello mathematicians, puzzlers, and other curious people. In this video, we are going to figure out what a parallelogram is from some examples and some non-examples. Let's get started. So here I see a Venn diagram that shows a set of parallelograms and then some things outside the set. So they're part of the universe, but they're not parallelograms. When I say the universe, I don't mean the universe we exist in. I mean the universe made up of these shapes. I notice here that our parallelograms are this one here, that if you turn your head sideways or if you rotate it, you might notice is really just a tilted square. Another example of a parallelogram is this rectangle right here. And then this shape here that is kind of similar to a rectangle in that it has four sides, but it doesn't have right-angled corners. It has slanted sides. Now, we also have these shapes that are not parallelograms out here. And here we have a shape that's called a trapezoid because it also has slanted sides. We also have this rather random quadrilateral here, and this hexagon. So here's one thing I notice. We've got a square, a rectangle, and this other parallelogram, and all of them have four sides. So one thing I notice is that parallelograms are a type of quadrilateral. So then the question is, what kind of quadrilateral do we call parallelograms? So I notice that the word parallel is right there in the name parallelogram. So one thing to ask about is, what is parallel about a parallelogram? So I see that the rectangle has this pair of sides that are parallel, and it also has this pair of sides that are parallel. I also notice that the square here has a pair of parallel sides right there, and another pair of parallel sides right there. I also see that this other parallelogram here has a pair of parallel sides here, and it's a little harder to tell, but both this side here and this side here are going 3 units up and 2 units over. So you can tell from the fact that they are both going 3 units up and 2 units over that these two sides are going in the same direction, as in they are parallel. Now let's look at some other shapes and see what's parallel about them. So I do see that this shape has one pair of parallel sides here, but this other pair of sides is not parallel. If you extend them, they intersect. I do not see any parallel sides at all around this shape. These two would intersect over here somewhere, and these two would intersect up here somewhere. Now, I do see some parallel sides on this hexagon. I see a pair of parallel sides there, and another pair there, and a third pair right here. So that hexagon has 3 pairs of parallel sides, but it's still not a parallelogram because parallelograms have to be quadrilaterals according to these rules that we're figuring out. So now I feel like I'm ready to write a definition. So I'm going to say a parallelogram is a quadrilateral with 2 pairs of parallel sides. And I think it's very important that we see how parallel shows up in the name as an important feature of the type of shape, and that's why that made it into the name. Now we might also ask, what else is consistent around these parallelograms? Now, I'm not going to say that these things would be true of all parallelograms yet, because we're only looking at 3 examples here. So I notice that parallelograms are sometimes squares or rectangles, but sometimes not. Squares and rectangles have identical angle measurements all the way around. This parallelogram is different. It has an acute angle here, and then it has an obtuse angle here. But one thing I notice about the parallelogram is if we flip it around, so I'm giving it a 180 here. If we flip it around, it looks like we have the same thing. So it seems to me to be the case that the opposite angles on a parallelogram have the same degree measurement. Certainly that's true on the rectangle where they're all 90 degrees and on the square where they're all 90 degrees. Another thing I notice is it looks like on a parallelogram, the two parallel sides seem to be the same length. The other side does not always seem to be the same length. It sometimes is the same length when the parallelogram in the first place, like all along, was a square. But on a rectangle, we see clearly that they can also be different lengths. But we do have two pairs of equal length sides and two pairs of equal measurement angles. And they're the ones that are across from each other. Later on in your geometry studies, you'll find some reasons why those things are actually things that are going to be true of parallelograms in general. And you'll also find out some names for specific kinds of parallelograms. You'll also find out some names for specific kinds of parallelograms that have some extra features that are consistent around them. Calculator!